So hi guys, so welcome to Scala crash course focused on functional programming stuff. So the idea with this set of sessions is give you strong knowledge regarding to functional stuff using Scala as programming language. So I'm gonna show you the resources for this course. The idea is that you practice as possible. We have this repo. I'm gonna share the link with you. So as you can see, we are going to show the basics of Scala. So the idea in this section is give you some a kind of tour for the language to show you the things that you can do in Scala particularly. Also, we have other functional concepts that we will see soon. So regarding to installation, I just left some instructions in our repo. The idea is you can follow. Also, you're able to use on a repo online, which is pretty useful when you need to do some in case that you are not planning install Scala. Okay. So if you have any question regarding to installation, just let me know. So let's see another bit. When you install, you will be able to see to use the Scala command. So this is the idea. You have an repo. This is a quick tour for Scala. Scala. Why Scala? Because the syntax is pretty similar to mainstream language. I'm talking about Java. The syntax is pretty similar. Scala, the version that Scala we are use is Scala 2. So because they use JVM, and it's most popular, we do not focus on the Scala 3 version just for now. So let's start to talk about Scala. In the Scala, we have two times two important times to think about when we write some code. First one is the compilation. So this is when the program must the Scala compiler check that our program is syntactically correct, and then you're able to execute or evaluate your program. This is the second time that you have to keep in mind. Also, Scala provides us a strong type language. Scala is able to infer types, which is cool. The language has a pretty non-verbose syntax, which is cool. And yeah, so in Scala we have to keep in mind three concepts for writing our programs. That is, for instance, the expressions are part of programs. The program's text that whatever we type in a file. This is just code for say something. So for instance, in Scala we have this expression. If expression, it's not it's not an command. So for instance, we have is, as you can see, they return any, because the expression is not complete. So now the expression it only must evaluate the same type, just for correctness or for make easy testing, things like that. We see if expression as an expression, not nor as an statement, which is pretty the first change that we have to keep in mind when you write some Scala program. So the type, for instance, in this this is an expression, as I mentioned it previously, and the type is the result of the evaluate that expression. So in this case, we have one string, and the value is the final result, the value that we will store in memory. That's a quick introduce for this. This is very useful when we start to talking about functional stuff. So we are able to create an integer, as I mentioned. Scala is able to infer the type. So this is the type int. We also are able to create a float. We also are able to create a double. Just we need those suffix, and as you see, the compiler infers the type correctly. We have also booleans. That could be true or false. Yeah, let's talk about a little bit more for strings. We are able to, well, help. A string, we are able, Scala provide us an interpolation stuff. So just we need the prefix s, the letter s, and also the dollar symbol here. And as you can see, we create a new string using the value previously calculated. So probably you will sometimes when it another result and then showing a raw value, we are able to do this. You know, it's a curly bracket, and then put any other expression, and it could be added to the string. This is a way to interpolation. So let's do this. So when we have a long string, so yeah, and a paragraph, we are not able to do this. We get an error. Also Scala. In Scala, we have the 3 quotes, and then we are able to include a big string, which is pretty useful. Sometimes this is pretty useful when we have a raw JSON, things like that. It's pretty useful. So let's talk about a little bit the functions. As I mentioned, we have this is some functional programming stuff. For you can imagine that we have strongly focused on functions. That's true. So we have the keyword def, the name of the function, and in brackets the set of parameters that we need to operate the functions. So as we mentioned, we are able to, Scala is able to evaluate, to infer the types. This is non. I mean, I recommend you put the types in the signature of the functions, because the compiler might infer anything that you don't expect. If you put a type, it's a little bit more safe. So for calling a function, just the name and just use the name and brackets the parameters, the arguments that you need to create. So we are able to set default values. So to call this function, just do this. We need, I mean, even if you define a default value, you need the empty curly, empty brace. If not, the compiler will say you that you need a parameter, even if it is a default. Okay. Also, we have function values. That's the idea is pretty similar to the normal function, but it could be assigned to a variable that could be named as a lambda function. In probably this concept is used in other languages, so we have this also here. we need the signature. This is a function that takes an integer and returns an integer. This is the signature of the function, and this is the implementation for the function. We are able to create a free variable and a free name, I mean. So we are able to do this. Spelling. No, you call the same as a normal method. This is pretty common in Scala. And then we also are able to write a compact syntax. This is just a wildcard to do our code less verbose, which is pretty useful when you want to stay focused in the things that you really matter in the program. So that's all for functions. So in the future we'll see why this matters. Probably when we talk in deep about functions. And yeah, so let's try to use complex objects or abstractions. That's interesting part. So in Scala we have also a class. So we have also, for mention for functions, you could use curly brackets, and we don't need a return statement because it's calling first, as I mentioned. Close this, then close the other one, and we define the class full. To create a new instance is pretty similar in other languages, pretty similar than in Java. We need the keyword new and the value. That's the idea. So not much new stuff for you, I think. But yeah, it works. Mention it for you. So we have also case classes with the keywords case class. So quick difference with a class, we don't for our parameters, they don't have a public access. So for instance, we can access to x value, x variable, sorry. So for this class, we don't need the first one is kind of syntactic sugar for create classes faster with less code, which is fine. uh, and yeah, there are a bunch of code that the compiler gave us when we create a case class. This is pretty useful when we start modeling domains. And yeah, these case classes allow us have very cool abstractions, so we don't need the variable. So as you can see, we have this value here, and then if we would like do the same for our class, we will need to define this explicitly. So you can see a bunch of verbose code could be uh, harder to read, to understand, things like that. This more compact way that's useful. Probably you will use classes for implement services, things like that, and case classes for model for our abstractions or domain objects. Probably could be if we are using an kind of similar of DDD. So also we have objects, Scala. Uh, an object in Scala is in a class with exactly one instance. That could be uh, and a singleton. I mean, my object, and we are able to create this. This also probably we will have this. Probably sometimes this interrogation mark, that means just a way to say, okay, we don't have implementation, but I don't want you fail because this just I promise I will think in a good implementation for this, but for now just compile. This is pretty useful when we start to thinking, just write our drafts, that kind of things, instead of throwing a non-implementation exception. For calling an object, as I mentioned it, because it's a singleton, we then need we have on a global instance. But the idea is you import the scope in the object, and we can do this. So that's the idea. So also we can import the object. This is looks like pretty similar when we define static functions in Java. That's the same. We don't need an instance, but we have, okay. We import all stuff from my object, and also now we have this. We are able to do this. know, but we import the object and we have the functionality. So there are another concept regarding to object is the companion object. So the idea is an object with the same name as a class. So we can override our constructors or put you know put final definitions or constants, I mean. So let's see. We have this. Also, we have the key, the default function apply. The idea is when we define the apply function, we are able to use an object as a function. And the technical name is functional application syntax, but it's just use the apply method. We can have this. This returns and timestamp value. And we have hours. We can override or create multiple constructors as we need. Okay, which is cool. And as mentioned, the function application is are able to do this. We have this final result. So this is pretty useful. Have things that you don't need for each instance that you create. You could put in the object and just use the memory in a good way. Don't waste memory if you don't need. So also we have case objects. This is pretty similar to um, the case class, but we don't have constructors here. Uh, that's the use case. An object or a definition that you don't need to create. It's some kind of constant value. We don't have uh, we are not able to change the value. That's a thing that I forgot mentioning to you. uh you know for months or things like that, you are able to create this. Also you wondering, uh I don't mention it now, but all values in Scala are immutable. That means when they get a value, we can change. That's the first thing that probably you will feel a little bit awkward. But yeah, is the idea. I will show you the details in the next sessions when we talk about the functional programming concepts that we have to keep in mind. So for now, that's enough. So for change the value, or we are able to do this. Is copy creates a new full definition instead of the replace that we we had. Okay, functional programming or functional languages have a lot of data structure that optimizes this stuff. So, for instance, let's continue with traits. The concept of traits is pretty similar to mainstream languages. The interfaces in so probably you the most useful thing is for polymorphic implementations, which is pretty useful. That concept for polymorphic is used also in functional programming. And yeah, I'm gonna show you a quick example for you. We have a sealed keyword. The idea is keep your abstractions safe. That means when we define a trade as sealed, we are not able to extend or create an implementation outside uh, the file that you provide the definition. That's pretty useful when we, compile your code, and we you probably will want to protect their implementations that you you have. In other languages, I see you have to do a lot of things to avoid this. So for now, in our example, we have a visitor abstraction. It's just for modeling a website. Um, we will have to do implementation for that. Difference between traits and, or for instance, Java interfaces is you are able to create or put the implementation for your methods. That means the methods not necessary and needed should be um, abstract methods. I mean, you are able to this. I'm gonna keep sailed definition for just for showing we can do this actually. So this is an example. We are able to create using the literal name. I mean, you don't need order. Uh, you don't need send the values order. That's I try to say you could do this. For the type. Yeah. Oh, I forgot the extension. We will get this illegal inheritance for sealed because it's sealed. Okay. So for our example, we will remove this, and now using this as anonymous user. We now are able to create this. Also, have a user logit, and we have two implementations for the abstraction visitors. So we need to override these methods. These methods we have to put the same. And also, you can create an extra information. That's polymorphic behavior. So we have a final concept that for now it's a pattern matching. So we are able to see pattern matching if an extended if expression that we can allow expressions depending on the shape of the data. Um, that's the idea. I'm gonna show you with an example. So for instance, we are able to create, we can create now an anonymous user. Anonymous. Uh, ID, that's it. So with pair matching, we are able to do that kind of things and a kind of deconstructor. But anonymous ID like yeah. Oh. We can use this wildcard. That means really don't matter. It don't matter the value for the created day. Uh, yeah, we deconstruct using this pattern, which is cool. Also, I'm gonna create an user. And we need an user definition and user mail.com. Now we are able to do the same. It's not an example. Other example using the explicit pattern matching syntax is uh, what user we passed our abstraction visitor, and we return a string. The final result. I'm going to show you this. So this is the syntax for pattern matching. We need the expression, in this case, the variable. We need the keyword match, and you start use cases. We use this wildcard premise similar here. Anonymous ID and date. Variable user is anonymous. With ID and date. It's just for show you sample. So the other case also, you need to be careful. We need to put all the possible cases because you will get an non exhaustive evaluation for this expression. You will you will need to provide all the possible cases. For this example, we just have user. User is and is a logged user with email. Email. So we need to close this. Then we close this. We are able to create what user. Let me see for use. And this is, as we can see, this is the case that the match detect and put the result. So this is pretty useful. As you can see, this is anonymous. And just for an example for you, I'm gonna delete this case just for getting the error that I mentioned. As you can see, match error. So in the real program, this probably won't compile because we don't have the full cases that we need to use for this. So hope you will learn a little bit more about Scala. I think this is a quick journey for the language, for the things that we can do. So probably the idea is you start feeling a bit more confidence. So I will see you in the next session with more stuff regarding to Scala. So thanks for for joining, and yeah, see you soon.